So we've done 5th normal form. Now it's time to push this baby into 6th gear. Welcome to this video on database normalization. My name is Kevin Fiesel, and I'm the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. So far in this series, we've hit on a series of normal forms. As I've mentioned repeatedly, I think Boyce Codd normal form and 5th normal form are the two most important. The third most important normal form is 6th normal form, though I include it in a tier below the best. Let's head to the classroom and find out why from our available professor. Hello, class. I almost didn't see you there, mostly because if you don't show up within 15 minutes, I get to cancel class and go home. To my dreary studio apartment, which is the only thing I can afford on this TA salary, eating cat food. Not even the good cat food, the dry stuff. But you probably don't want to hear about my travails. No, we're here to talk about 6th normal form. 6th normal form slots into the A tier, the only normal form to do so. And today, we're going to understand why it belongs in this position. The definition of 6th normal form is a relvar R is in 6th normal form if and only if all join dependencies which hold an R are trivial. What this means in practice is that there may be, in addition to the key columns, one additional attribute. Let's see an example of this. Here I have on the whiteboard a relvar very similar to one we talked about in 1st normal form around repeating groups. We have an album ID and name, the album runtime, the release year, 2 artists, and 3 genres. Let's say, for the sake of argument, that album ID is our natural key and serves as the only candidate key for this relvar. Because of this, the relvar is in 5th normal form. We know this because it's in Boyce Codd normal form, as all functional dependencies derive from the album ID, and because our key is a single attribute. That makes it 5th normal form. It is, however, not in 6th normal form. Here's how we can make this into 6th normal form. We create one new relvar for each combination of our key and a single attribute. So we'd have a relvar for album and name, a relvar for album and runtime, and so on through the list until we get to a relvar for album ID and genre ID 3. This seems like overkill. And that leads me to an important question. Do we actually need to be in 6th normal form? The answer is a firm maybe. Here's my take on the matter. First, if an attribute always has a value, that is, we are free of the dreaded null virus, then it's probably better to cluster those attributes together on a single relvar. But if an attribute might have missing information, then we could benefit from breaking it out into 6th normal form so that we avoid null. This is how we square the database design circle of normalizing our database, knowing that 1st normal form prohibits null, while still maintaining a path for missing values. If we have a value, we have a tuple in the 6NF relvar. If we don't have a value, the answer is unknown, providing us the same informative value as null, but none of the database design headaches. Finally, if we have a nested set like 3 genres or 2 artists, we can unpivot all of these into one table. We don't need a relvar for album in genre 3 and a relvar for album in genre 2 and a relvar for album in genre 1. We need a relvar for album and genre, and we can have multiple tuples associated with a single album. If we absolutely need to know which is the 1st or 2nd genre, we can add that as an attribute on our new relvar, which is okay because in that case the key is album plus genre, and the single additional attribute is rank order, and we could put a unique key constraint on rank order to guarantee no messiness. So let's go back to our example here. Let's suppose that we don't always have runtime, and that we find the idea of multiple artist and genre attributes distasteful. Following my recommendations, we would then have 4 relvars. The first would include album ID, name, and release year, as these attributes are mandatory for an album. The second would include album and runtime, and we would only enter a tuple in here if we know the runtime of that album. The third is album and artist ID, and we would have however many tuples we need to cover all of the artists. The same goes for album and genre. The other place where 6th normal form can be quite helpful to us is when we work with intervals of data. Let's suppose that we have some bands going on tour in different cities. Bad Religion is in London from the 4th through the 8th. Horror Pops is in Paris on the 3rd and will then be in Athens from the 5th through the 10th. We've packed this information into the minimum viable format. One tuple containing an interval of days per band and city. That's some nice efficiency. But let's use a more complex example. Here we have a headliner and a warm-up artist, as well as the city, the start date, and the end date. This would be the type of thing we might see in a Type 2 slowly changing dimension. Each artist is in a particular city for some range of days, and each artist has a warm-up band. As warm-up artist or city changes, we mark the end date and add a new tuple. But we don't need to store these 5 tuples with redundant data if we're using 6th normal form. Instead, we should realize that headliner is the driving force, and city and warm-up are independent attributes, so we can move them into 2 separate relvars. For each relvar, we'll add an interval based on the key being headliner and city, or headliner and warm-up respectively. Then, if we want to bring this data back together, we unpack the intervals, join the 2 relvars together based on headliner and day, and repack on interval. That transforms our results back into something that looks like this Type 2 slowly changing dimension, meaning that we add no rows, we lose no rows, guaranteeing data correctness in the transformation. To make it a little clearer, here's a depiction of headliner and city, as well as all of the days we care about. A headlining band is in a city if the day box is blue. Here's a list of headliners and warm-up bands. And again, a warm-up band is going in front of the headliner on a given day if the box is highlighted in blue. The next step is to unpack this data. Let's do that for Bad Religion. In this image, the warm-up band days are highlighted in green and the city days are highlighted in blue. We can break this out into a tall relation, including artist, warm-up band, city, and day. This gives us 17 tuples, each representing a day that the headliner band is performing in a city with a warm-up band. Then we can find ranges in which our input criteria match and then pack them back down, leaving us 3 tuples with 3 separate date ranges. This leads me to my final guidance on 6th normal form. If you hate null, like I do, then use 6th normal form to get rid of null. You could go further and make everything into 6th normal form. Anchor modeling, a particular technique for temporal database design, shares a lot of similarity with 6th normal form. But generally, what we see is that the base tables are 6NF, but practitioners then create a series of views which join these tables together into something looking more like 5th normal form. So it does work, but I don't see a huge benefit for this approach outside of cases where we need to track data across intervals of time. There is a performance hit from breaking out tables in a database, so for those few critical path tables in a database, where we absolutely need performance to be as good as possible, and yet there are nullable columns, I might bite the bullet and leave null. But regardless, I'd at least consider building a 6th normal form design. Remember that the logical data model does not need to line up with your physical data model. The physical data model embraces the fallen nature of man, but the logical data model allows us to conceptualize the Platonic form of that database. On that note, class dismissed, mostly because otherwise I'll start ranting about Plato again. That was 6th normal form. If you've been following along, that will mark the final normal form that we'll cover in this series. There are, of course, normal forms beyond that. After all, academicians need to eat too. But I'd consider those additional normal forms to be esoteric. Yeah, I think esoteric is the kind way to put it. In the next video, we'll wrap up this series, so stay tuned for it. We'll have links and show notes in the description below. And until we see each other in the next video, take care.